All right, welcome to lesson 33. This is the second lesson in our third unit. We just did lesson 32 where we were doing an introduction to graphing. We talked about plotting points and we graphed some lines. Most of this unit will be covering topics related to that, but this one is kind of a little bit different. We're talking about functions. So we will be looking at some graphs, but I'll just say this lesson is different from all the other ones. It has more vocabulary in it. It's just different. So let's just find out and get started. All right, so speaking of vocabulary, let's look at our first word here. So we're going to be talking about relations. A relation is a set of ordered pairs. Now, a certain type of relation would be a line. That's a set of a lot of ordered pairs, a lot of points actually, an infinite number of points. And certain lines, most lines that we will be graphing, are not only relations, but functions. But I'm getting ahead of myself. So a relation is just kind of like a relationship, where maybe a relationship is a pair of people, possibly. A relation is a set of ordered pairs. There's x coordinates and there's y coordinates. So this particular relation is 3 different ordered pairs. Each one has an x coordinate and each one has a y coordinate. Okay. So we'll just start there. I'm going to just label my x and y coordinates here. We have x and y, x and y, x and y. Okay, now if I were to split this relation up, there's 2 parts. There's the domain, that's all the first coordinates or all the x coordinates, and then there's the range, which is all the second coordinates or the y coordinates. So you can see how they've been kind of split up into their own separate sets. The domain of this relation includes all the x coordinates, 1, 3, and then there's this 1 again, but see how we didn't list it twice in the domain. We just listed it one time. Okay, so if you see an x coordinate or a y coordinate being listed more than once in a relation, you do not need to list it more than once in the domain or the range. So no repetition when you're listing things in the domain or range. The range, the set of all the second coordinates or the y coordinates, that would be 2, 4, and 5 right here. Now the next thing I'm going to do is I'm going to draw some arrows to show how these points or numbers relate to each other from the domain to the range. Okay, so with my first ordered pair, 1, 2, we could say that the number 1 is paired with the number 2. So 1 goes to 2. Then 3, 4, we could say the number 3 is paired with the number 4. So 3 goes with 4. Everything looks good so far. See how we're kind of out of numbers in the domain? What's supposed to go with 5? Well, here's this third point over here, 1, 5. So what's about to happen is I'm going to draw a second arrow coming off of the 1. So in a way, if I think about a relation almost like a formula, if you plug a number into a formula, you should expect to get one answer, right? If that happens, you have a function. If it doesn't happen, you don't. So this right here is not a function because of this strange arrow diagram I just attempted to draw. Because this number 1 in the domain is paired with 2 different numbers in the range. It's almost like I'm plugging in the number 1 and getting 2 answers. A function, let's look at the definition down here. A function is a relation in which each domain value or x value is assigned to exactly one range value or y value. So each x goes with exactly one y. What you don't want is that x value going to 2 different y's. So back up here in our original list, as soon as we saw this number 1 appearing in 2 places, if you have an x coordinate that's appearing in two different ordered pairs, that's another clue that you don't have a function. Okay, so the relation above is not a function because the number 1 in the domain is paired with 2 different values in the range. This is about the time when I would pause the PowerPoint in class and maybe just say a little bit more about this. So what I'm going to do right now is we're going to go to the whiteboard here, which means I'm going to share a blank screen with you. Okay, so here's another way of illustrating a relation. You have a domain and you have a range. So we had 1 going to 2, 3 going to 4, and then 1 also going to 5. So this is sort of another way of writing kind of an arrow diagram, I guess, kind of like what we did before. 1 goes to 2, 3 goes to 4, but then, oops, 1 also goes to 5. That's not okay. It's a relation, but this is not a function. Okay, so what would be an example of a function? Well, if this didn't happen, right? So I think what we're about to see in the next slide, when we get back to the PowerPoint in a minute, we will see an example of something that is a function. An example I'm going to do with you right now, this might seem a little bit strange. I'm going to use an example with names and grades. Okay, and if I use your name, just be flattered. Some of these names might actually come from our classes, some might not. Okay, so I have a class of 3 students, Alex, Bob, and Carl, or Alex, Barb, and Carl, sorry. And then here are the grades I'm gonna give in my imaginary teaching scenario. Here's what I'm gonna do. Alex earns an A. Barb earns a B. Carl earns a B and a C. What? See how that makes no sense? I can't give Carl 2 grades. So this is a problem. This is another example of not a function. Okay, because Carl is apparently getting 2 different grades in this class. That's not allowed. Okay, grades only make sense if you earn exactly 1 grade for the class you're in. If you earn multiple grades for that one class, how are you supposed to know which one is the real one? Okay, everything kind of falls apart. So this is another example of something that is not a function. I can't give, just make a little note here, I can't give students, or I can't give a student more than 1 grade. So this can be maybe an analogy that helps you start to understand relations and functions, okay? So this is the one I always come back to. I'm a teacher, so I think about grades. You could easily replace grade with age, right? One person can't be 2 different ages at the same time. That's another analogy that could work. You can't be 18 years old and 19 years old. You're either one or the other. So that's another example. I'm gonna go back now. Let's take a look at another example in our notes, and I might come back to this grades and students analogy, but let's go back to our notes here. Okay. So I think we covered what was on here on our first slide. Let's go to the next slide. Okay, so here's another example. We have a relation. This time there's 4 ordered pairs. State the domain and range of the relation. Determine whether or not it is a function. Okay, that sounds very manageable. Let's try. So our domain is all the x coordinates. There's 6, 4, 9, and 2. 6, 4, 9, and 2. Okay, hi. I'm being interrupted here, and that's okay. I'm going to pause the recording just for a minute. Okay, so we were just talking about domain, how domain is all the x coordinates, 6, 4, 9, and 2. Now let's do the range, and let's change our color here. The range is going to be all of our y coordinates. So that's 7, 8, 0, and then here's the number 8 again. I'm not going to repeat it, so I'm just going to write 7, 8, 0. Now earlier on the whiteboard, that blank screen when I was writing, I drew something called a mapping, and I want to draw that for you again here. So here's our domain and our range, and we're just going to list our numbers and draw some arrows. So 6 goes to 7, 4 goes to 8, 9 goes to 0, and then squeezing in down here, 2 also goes to 8. Okay, so I want you to look in the domain how each number has only 1 arrow coming off of it. So even though there is some repetition in the range, this is still a function. We would say yes to this one because each number in the domain is paired with exactly 1 number in the range. Okay. Okay, let's go back to the whiteboard now, that blank screen, because I want to do another example using students and grades, just to kind of illustrate this a little bit more. Okay, so earlier we saw this example where we had Alex, Barb, and Carl. Alex got an A, Barb got a B, Carl got 2 grades. That didn't make any sense. That wasn't a function. I'm going to do a similar example right now. So we have domain, we have range, Alex, Barb, and Carl are back. This time, Alex gets an A, Barb gets a B, and Carl also gets a B. This is fine, right? Each student gets a grade. Each student gets 1 grade. Alex gets an A, Barb gets a B, Carl gets a B. Now, is it okay for 2 students to get the same grade? I certainly hope so, right? Because in most classes, or many classes, I could have more than 26 students and there's more than 26 letters in the alphabet. And really, the grades that I want to give are probably just A, B, and C in most classes. And for this class, hopefully all of you will get a P for pass, right? So you're all going to get, hopefully you're all going to get the same grade. So this is a function. So to compare it to the last example, it's okay for 2 students to get the same grade, which means it's okay for there to be repetition in the range. It's okay for us to see 2 different y coordinates when we see a list of ordered pairs. That's okay in a function. What you want to look at is when you start with something in the domain, it should be matched with exactly 1 element in the range. It's kind of like plugging into a formula. When you plug something into the domain, it should pop out exactly 1 answer in the range. Alex gets 1 grade. Alex gets an A. Barb gets 1 grade. Barb gets a B. Carl gets 1 grade. Carl gets a B. It works. This is a function. Okay, so that's kind of similar to our example that we just saw. Oops, I'm going to go back to the slide we were just doing. Sorry about that. There we go. Okay, so again, this example, yes, it's a function because each number in the domain is matched with exactly 1 number in the range. It's okay that we had this 8 appearing twice in the range, okay? It's kind of like 4 goes to 8 and 2 goes to 8. It's kind of like 2 students getting the same grade. It's fine. This is a function. If you look at the arrows, nothing in the domain has more than 1 arrow coming off of it. All right, so let's keep going. What we're going to look at now is a different type of how to illustrate a relation and a different way of deciding whether a relation is a function. So what we see here in red, these kind of U shapes, these are called parabolas. Now, sometimes these graphs represent functions and sometimes they don't. And there's a pretty straightforward way of telling whether a graph represents a function or not. And it's something called the vertical line test. Okay, so let's take a look. I think there's more on this slide I want you to see here. All right, now if I look at this first graph here, this kind of sideways looking parabola, it's sort of opening towards the right. The domain, we want to look at what are all the x values in this graph. Okay, so the lowest x value on this x-axis, the lowest number is this 1 right here. Okay, so I'm going to try to illustrate that for us here. We'll do the highlighter. Okay, so I'm almost drawing a boundary here. The domain starts at 1, and then we go to the right. And this would continue past our graph. So our domain is all values of x that are greater than or equal to 1. That's our domain. Our range, what are the y values on this graph? Well, this graph actually doesn't stop, even though on our paper it does. This graph does go on forever. Okay, so this shape of the parabola, it continues to get wider and wider. So there's no limit to what the y values are. We would say the range is all real numbers. Now, back to what we were talking about before, the vertical line test. We want to tell if this graph is a function or not. So I want you to look at these 2 points here that have been labeled for us. The first point, I would say that's probably 3, and let's just kind of guess here. maybe, let's say 1.2. The exact value isn't really important. Somewhere between 1 and 2. What about this point down here? The x-coordinate is 3. This time the y coordinate is probably something like negative 1.2. See how there's repetition here in the domain? The number 3 is going 2 different places. 3 is being matched with 1.2, and 3 is also being matched with negative 1.2. That's kind of like when we saw earlier the same student getting 2 grades. This is not okay. So this is not a function. And a quicker way to tell is you can just take a vertical line and draw a vertical line up and down through your graph. If it crosses more than once, then you know that your graph is not a function. Okay, so this graph is not a function. We would say it fails the vertical line test. Okay, as soon as we see, oops, let's erase that, it's messier than I expected. As soon as we see a vertical line passing more than once, we would say that our graph fails the vertical line test. Okay, just gonna erase this here as well. Okay, I wanna put it back because I did want you to have that little arrow diagram. So 3 was going to 1.2, as well as negative 1.2. And that was not okay, right? So this x value of 3 was matched with 2 different y values. This is not a function. Okay, so a quick way to tell if a graph is a function, just draw a vertical line through it. If it crosses more than once, then you'd say no, it's not a function. Whereas over here, the second example, see this blue line going up and down, crossing the graph exactly once, we would say this graph passes the vertical line test. Okay, so it passes the vertical line test. So this is a function. Now earlier in the other graph, we were talking about domain and range. The answers are kind of the opposite here for this graph. The domain, this parabola will get wider in both directions without limit. So there is no lowest x value on this graph, and there is no highest x value. It goes on forever, and it gets wider and wider. So that's why we say our domain is all real numbers. However, with the range, let's take a look at our range here. There is a limit to what y can be, right? So there is a lowest point on this graph. The lowest point, we're talking about up and down, this is kind of our boundary, right? There's nothing below this green line that I just drew. The graph goes up forever. So our range starts down here at -1 and just goes on forever after that. So we would say our range is the set of all y values such that y is greater than or equal to -1. Okay, so our domain is all real numbers, but our range is y is greater than or equal to -1. Okay, so I know domain and range, based on these graphs, I know that's really tricky and you might find yourself being confused right now. You'll get used to it. We'll do some more examples. It's very visual, so I do recommend having different colors. If you're able to print out the PowerPoint and color on it, that's good. Otherwise, just kind of sketch the graphs and kind of practice shading those x values and y values until you get used to the domain and range in this more visual way. I know that's tricky. The main thing from these two examples, though, is that vertical line test. So draw a vertical line through your graph. If it crosses more than once, then it fails the vertical line test and it's not a function. If it only passes through once, then it passes the vertical line test and it is a function. Okay, good. Let's keep going. So nice and easy and quick. Is this the graph of a function, yes or no? All right, so what we're going to do is we're going to draw a vertical line through the graph. How many times did the line cross through this strange zigzag graph? Well, I drew a vertical line and it only crosses once. Now I can try again, just to be sure, but anywhere you draw a vertical line through this graph, it will only cross once. So we would say, yes, this is a function. Let me change that back to a pen here. So yes, this is a function because each vertical line crosses only once. Okay, so each vertical line crosses, sorry, move that out of the way, crosses only once. All right, and then for this other example, this kind of looks like an oval here. Is this a function? Well, let's draw a vertical line through the graph. Really doesn't matter where. What you should notice, no matter where you draw a vertical line, is that it's actually crossing twice. So crossing more than once, that means it's not a function. So we would say no. This one's not a function. It's a graph, it's a relation, we can still talk about it. This is actually called an ellipse, kind of looks like an oval, but it is not a function. And you can see these 2 points that I've circled, they would both have the same x coordinate, right? So they both have 2 as their x coordinate, okay? And that's the thing we want to look out for, right? We don't want to see that repetition in the x values. So if I plug in 2 to this formula, it would give me 2 different answers. That's not okay. That's not a function. But again, the quick, easy thing we can do is just draw that vertical line and count how many times it crosses. If it crosses only once, yes, you have a function. In this case, it crosses twice, so no, no function. Not a function. Okay, we're going to move on now to something called function notation. So I've been comparing functions to formulas. You have plugged into formulas before. So plugging into a function is really the same thing as plugging into a formula. So there's this new notation called f of x. So when you see this f parentheses x, we say f of x. It's really like a name for a function. So instead of y equals, sometimes you might see f of x equals. It's the same thing. Okay, so when you have f of x equal to something, that's an indication that what you're dealing with is a function. It's essentially a formula, and you can plug into it. Okay, so finding the value of a function, that basically means you're plugging a number into a function and you're getting an answer. Okay, so I purposely picked some slightly trickier examples here. Here's a function, f of x equals 7x plus 2. This is a line. We, just like in our last lesson, how we made a table of values, we could plug almost anything we wanted to in for x to get a corresponding y value. Okay, and we're going to plug in 3/7 for x in our first example. F of 3/7, that means we're going to replace x with 3/7 in our function, in our formula, basically. Okay, so 7x plus 2, I'm writing 7 times 3/7 plus 2. And then I'm going to simplify. So just some order of operations. We're dealing with a fraction here. That's okay. 7 times 3/7. The 7s actually cancel out because 7 divided by 7 is 1. So this turns into 3/1, or 3 plus 2, which is 5. That's it. That's our function value. So f of 3/7 is 5. What that means is on this graph, one of the points on the graph is 3/7, 5. So when x is 3/7, y is 5. Okay, good. Let's do one more. This is obviously different. We're plugging in variables rather than numbers, so that maybe seems a little strange, but it's still the same idea. Okay, so here's my formula, 7x plus 2. I'm replacing x with a plus h. Okay, so instead of 7x, I have 7 times a plus h. Now, since there's 2 variables there, I'm just going to distribute the 7. 7 times a is 7a plus 7 times h is 7h, and then I still have the plus 2. And believe it or not, that's our answer. So that's a little strange to have such a long answer. That still counts as a function value. There's some variables in there, and all I will say is you'll get to see this type of thing much, much later in pre-calculus or calculus when we do a lot of plugging in variables into functions. But all you needed to do is just replace x with a plus h and just distribute the 7. That's all. And these three terms, just recognize that they're not like terms. And that's it. So hopefully it's not as hard as it may have looked. All right, we're going to do a few more examples of functions. This next function has absolute value. So what I need to remind you about absolute value is that it's distance from 0, and distance is always positive. Okay, so the absolute value of a number will become positive if it's not already. All right, so for part A, k of -5. Now, instead of f of x, we see k of x. It's the same idea. It's just a different name of a different function. The letter doesn't really mean anything right now. So we're still going to plug in the same way. We'll replace x with our x value right here. We'll replace x with -5. So instead of absolute value of x plus 3, we have absolute value of -5 plus 3. The absolute value of -5 is 5. Because remember, absolute value is positive. Distance from 0, always positive. And then we just simplify. 5 plus 3 is 8. That's it. So our function value here is 8. So what this means is when x is -5, y is 8. And now we'll just do a couple more. Okay, our next problem, we're plugging in 9 for x. The absolute value of 9 plus 3. The absolute value of 9 is just 9. How far away is 9 from 0? It's 9 units away. Okay, so absolute value turns a negative number into a positive, but if your number is already positive, it just stays that way. So the absolute value of 9 is 9. And then 9 plus 3, 12. So that is our function value. When x is 9, y is 12. Then we have one more of these to do on this particular function. Here's another one with a variable. So it's going to look a little strange because we're plugging in a minus 3 for x. Okay, so k of a minus 3, we will replace x with a minus 3. And we're done. That's it. So usually students think there's more to do here, but the thing is we don't know what a is. So a minus 3 could be positive, but it also could be negative. We don't really know. So we are not able to simplify what is in the absolute value here. We don't know if it's positive or negative, so we have to just leave it. Okay, so what I will say is on the homework, when you see some kind of strange looking functions with absolute value or radicals, don't overthink it. Okay, sometimes when you're plugging in those variables, you plug in and then you're done. And that is the case for this one here. Okay, looks like we have one more function to do. This one is g of x, and this is called a quadratic function. We have a variable with an exponent of 2. You saw those a lot when you were factoring. So this graph actually is a parabola, but you don't need to know that. All you need to do is be able to replace x with -3. Okay, so g of -3. I'm replacing x with -3. Now notice what I've done here. Everywhere there's an x, I just kind of made like a blank spot to fill in. I'm filling in the blank. And wherever I see an x, I'm replacing it with -3. And I'm going to be extra careful with order of operations and with negatives. Okay, so let's simplify. Be careful, don't multiply. You want to start with exponents here. So start by squaring the -3 and getting 9. Okay, oops, going back here. Okay, sorry, I had a little pause there. We were replacing x with -3. -3 squared is 9. And now I'm just copying down everything else that we have. It's just order of operations now. 2 times 9 is 18. Think of this as -5 times -3. That becomes positive 15. And then we just add them together and we get 33. So be aware of the many different places here where you could make a mistake, mostly to do with negatives. So -3 times -3 is positive 9. -5 times -3 is +15. So any number of things could have been done wrong here. Just be careful as you always are. Okay, next example, plugging into the same function. This time we're replacing x with 4a. Okay, so 2x squared minus 5x. Again, I'm leaving some fill in the blank spots. This time I will replace x with 4a. Okay, last time we had a variable, there was not any simplifying we could do. There is a little bit here though. So let's work left to right. I can square the 4a. 4a times 4a is 16a squared. And I still have the 2. So I'm going to bring that down. Okay, so I did exponents first. Now I'm going to multiply. 2 times 16a squared is 32a squared, minus 5 times 4a is 20a. And now I'm done. Okay, so when we plugged in 4a, we simplified by squaring the 4a, and then we had to multiply that by 2. We multiplied 5 times 4a and got 20a. Our final answer here is 32a squared minus 20a. So this might feel a little bit strange to you how we have variables in our answer. When you plug a variable into a function, you're kind of left with a new function. So it doesn't seem as satisfying as getting a number answer. I realize that. It's almost like you're starting with one formula and ending with another formula. So that's one way to think about it. But just plug in, replace the variable, replace x with whatever you're given, simplify whatever you can, and then you'll get to a point where you can't do anything else, and then you know you're done. And we're done here because these terms are not alike. Because one has a 2 exponent and the other one does not, so we cannot put them together. Okay, we've come to the part of our lesson where we get to look at some graphs again. Okay, so we're going to now find function values from a graph. All right, so let's take a look. F of -5. Now we have no formula to plug into. This is a strange looking graph. It's just a bunch of points. So what we want to know here is when x is -5, what is y? Okay, so the point we're looking for on the graph will have an x coordinate of 5. So let's find it. All right, so I'm going to change my color here. So let's go to our x-axis. Here's -5. Here, right here is the point we're looking at. So it looks like when x is -5, y is 5. So we have done it. We have found our function value. Okay, so f of -5 is 5 because when x is -5, y is 5. That's really the reason. Okay, next question, domain. All right, we did see some examples of domain earlier. They involved kind of highlighting, and that was possibly confusing. The domain here is a simpler answer because it is just a list. So there's not an infinite number of x or y coordinates here. There's 1, 2, 3, 4, 5, 6. There's only 7 points on this graph. So at most we have only 7 values in the domain, and we do. So I'm going to name each x coordinate from left to right. The first one I see here is -6. Sorry, I keep doing that. The next x coordinate is -5, then -4, then -3, -2, -1, and then the last one here is 0. That last point on the right side is 0, 6. There we go. Okay, so my domain, remember domain is all the x values. Okay, so I just made a list here. Usually you're not able to list them. It's more of an inequality because there's an infinite number of points. But in this case, there were only 7 points. So I was able to list the 7 values of the domain. Okay, I'm going to skip ahead here. I like to do the range next. Okay, I think I based the order here off what you'll see on the homework, but I do want to name the range with you while we're while we're talking about domain and range because they're so related to each other. Okay, so the range, that's all the y values. Okay, let's name those in a list from least to greatest. Now, that means instead of from left to right, we'll go from down to up. So the lowest value on our graph, the lowest point on our graph, if we're talking about y coordinates, is this point right here. It has a y coordinate of 3. That's the lowest y value in our range. Okay, now if I continue up, there's 2 points that have the same y value here. They both have a y coordinate of 4. I'm just going to say 4 is our next y value. Then there's 2 points that have 5 as a y coordinate. So 5 is also part of our range. And then finally, there's 2 points that have 6 as a y coordinate. So look how much shorter our list is here for the range compared to the domain. Now, if we made a list of each of these ordered pairs, we'd see quite a bit of repetition in the range. And in fact, maybe we'll do a little mapping here. Okay, so if I go left to right, right here, -6 goes to 6. -5 goes to 5. -4 goes to 4. There's the pattern. Okay. -3. Where are we? Here we go. -3 goes to 3. And then the pattern breaks. Okay, I'm out of space here, adding on to the domain. Whoop, that's still all part of the same group. Okay, let's change the color so we can see it a little more clearly here. Okay, -2. This point right here. The y coordinate is 4. Okay, so -4 goes to 4, but -2 also goes to 4. 2 students getting the same grade, right? This is a function. It does pass the vertical line test. There's no place where you could draw a vertical line and it would cross twice. Okay, and if I were to keep going, -1, that's this point here, that goes to 5. A little bit of a messy arrow diagram at this point, and then our last point, 0, 0 goes to 6. Okay. Anyway, not sure if that helped or not, but I did want you to see that if you were to kind of sketch it out in this way, some of those range values have more than one domain value heading to it, but for each value in the domain, for each x coordinate, there's only one arrow coming off of it. Okay, so that might help explain why the domain list is so much longer than the range list. Oh boy, okay, good. Let's go back to part C that we skipped. All right, so we are being asked to find any x values for which f of x equals 6. What does that mean? Okay, we want to know what are the x values for which or where y is equal to 6. So just a reminder, when you see f of x, I want you to think y. So what are the points that have a y coordinate of 6? And there could be more than one. I think if you look at our messy green arrow diagram over here, you might remember, or we can look at the graph as we're supposed to do. These are our 2 points right here. There's 2 points that have a y coordinate of 6. One of them is 0, 6, right here on the y axis. Then there's another one over here, -6, 6. So it happens twice. So the x values are 0 and -6. Those are the 2 x values. Okay, so probably on the homework you'll just list them. Okay, 0 is one of them, and then -6 is the other one. Both of those have a function value of 6. When you plug them in or when you look at the graph, when x is 0, y is 6. When x is -6, also y is 6. All right, good. We're going to go through that a little bit more for a couple more graphs just to get some practice. And in case you can't tell, these are essentially screenshots taken straight from your homework. So I do hope that this helps when you get to those problems. You pretty much have what you need at this point, but I'm just trying to show you some variety because I know this can be very challenging. These graphs are pretty strange. Okay, so let's look at another one. We'll start with f of -2. Okay, so when x is -2, what is y? Okay, so here's -2 on the x-axis. Where along this line here would I find a point on the graph? And it looks like right here. This is the point on the graph that has an x-coordinate of -2. And I would name that point as -2, -4. So that means f of -2 is -4. When x is -2, y is -4. Okay, now let's talk about domain. Domain is all the x values. I can't list them all in this graph. It's not just a set of points. It's not just a set of dots, I should say. It is a set of points, but it literally goes on forever. This graph continues to get wider in both directions. Okay, I know the arrows are pointing up and down, but if you imagine the shape continuing as it is, it gets wider to the right and wider to the left. So we would say the answer here is all real numbers. Okay, for a lot of the kind of strange looking graphs you're going to see, that's going to be your answer for the domain. So when in doubt, you can choose that. Not every time, but a lot of times that is our answer for the domain. All real numbers. Okay, and that's going to be our answer for the range as well for this one. So the range, all the y values, kind of the same reasoning. This graph goes up forever and down forever. So there's no limit on our y values. Our range is all real numbers. It literally goes on forever. Okay, so that's different. We can't make a list. I can't make a nice diagram of that. If I tried to list everything in the domain, I would just never be done. Okay, so our domain and our range for this graph, all real numbers. Let's look at our last question, which we skipped. I'm doing it out of order. Let's use orange here. Any x values for which f of x equals 8. Okay, so remember f of x is the same thing as y. So we want to know on our graph, where is y equal to 8? So last time there were 2 answers. This time it looks like there's really only one point that has a y coordinate of 8. It's right here in orange here. And the x coordinate would be 4. So it looks like our point here would be 4, 8, which means the x value, there's only one, is just 4. Okay, one way to say this is f of 4 is equal to 8. When x is 4, y is 8. Okay, so what we're doing right now, this is called analyzing a graph. We're really getting into a lot of details related to these graphs. And I know this is very strange and you're probably feeling a little overwhelmed. Some of the graphs look pretty confusing. You're not going to have to create any of these graphs. You will be given a graph to answer these questions. And I think you'll feel better in our next lesson when you're back to just graphing lines and looking at lines. But we have one more strange graph to look at. Okay, this is actually an absolute value graph, in case you're wondering, which you might not be. All right, but we're just going to look at it as it is and answer some questions about it. All right, so let's start with the first one, f of 1. Okay, f of 1. So when x is 1, what is y? Here's 1 down here. There should be one point on the graph that has that x value. There it is. Looks like our y value is 5. So 1, 5 is on the graph, which means f of 1 is equal to 5. That's it. Okay, so when you're answering a question like this, finding a function value, there should be exactly one answer. Okay, f of 1 should have one answer. When I plug 1 in for x, I should get exactly one answer for y. Otherwise, we would not call it a function. Okay, next, the domain. Just like last time, this graph gets wider in both directions. It goes on forever to the right and it goes on forever to the left. So again, we get to say all real numbers. Okay, I'm going to go in order for this question. So I'm going to save the range for last. Let's go to part C. Any x values for which f of x is equal to 3. Okay. We want to know when when would y be equal to 3 on this graph? And it actually happens more than once. Here's 3. Here are the 2 points where it happens. Okay, so these 2 points, let's name them. We have 3, 3, and then we have 9, 3. Okay, so there's 2 different places where y is equal to 3. So the x values of those 2 points are 3 and 9. 3 and 9. Those are my x values because f of 3 is equal to 3 and f of 9 is equal to 3. Both of those things are true. So there's 2 different points that have the same y value. Is that okay? Yes, just like it's okay for 2 students to be assigned the same grade or for 2 people to have the same age. Okay. Finally, last part of this multi-part question, the range. Okay, time to get my highlighter out. Now, the domain was all real numbers. So you might want to just write all real numbers, except that's not the answer for the range. I want you to notice that there is a lowest y value on this graph. Okay, the lowest y value, I can kind of draw a boundary line for my graph here. The graph doesn't go below here. The lowest y value is kind of this point here, this sort of point or corner of the V shape. That y coordinate is 0. Okay, so that's the lowest value of y to be found on this graph. There's no negatives. In terms of the points on this graph, there's no points that have negative values of y. The graph does continue up forever. Okay, so we do continue up this way, but there's a lowest value. Okay, so I would say, how would we answer that then? Let's write it out. Okay, so I would say it's the set of all y such that y is, okay. Now, on the homework, all of this will be laid out for you. You just have to fill in the box right here. That's all you have to do. Okay, so it's the set of all y such that y is greater than or equal to whatever this lowest value is, and that lowest value is 0. So you just have to fill in that number, which is 0. Okay, now you might have choices. One of the choices might be all real numbers. One choice might have a less than or less than or equal to. We definitely need the greater than or equal to because we're going up. We're going in that up or positive direction for the range. Okay, good. So probably this was new for most of you, so you might feel a little bit confused or just a little bit overloaded with some new images and new vocabulary in this section. You'll probably be a little more comfortable with the stuff that comes after this. It'll be more familiar to what you may have learned in maybe a high school algebra class. This might be different. So take advantage of all the homework that you have and see it as an opportunity to practice. Keep clicking Ask My Instructor on any graph that gives you some trouble, and I'll try to write back and do all kinds of screenshots and coloring and hopefully help you out in that way. But come back and refer to these because you might actually recognize them on the homework. Okay, good. So I will end the video here. This was lesson 33. And just a reminder, in this 3rd unit, we're covering lessons 32 through 38. So at this point, you should have gone through 32 and 33, and just a few more to go after that. Okay, thank you.